Building a transparent supply chain is a must for any logistics or supply chain company today. And blockchain is the perfect solution. Blockchain is this digital record keeping technology behind Bitcoin and other cryptocurrency networks. It's a potential game changer in the financial world and many other industries. But another area where it also holds great promise, as stated, is supply chain management and logistics industry, which is one of the top 5 largest industries in the world. And blockchain can greatly improve supply chains by enabling faster and more cost-efficient delivery of products, enhancing products traceability, improving coordination between partners, and aiding access to financing. To better understand this opportunity, we will take a look at 7 major U.S. corporations that are leaders in supply chain management and looking at how blockchain can solve their challenges. These companies are Corning, Emerson, Hayward, IBM, MasterCard, and 2 others that are anonymous here that operate in varied industries, which include manufacturing, retailing, technology, and financial services. And some of them are just beginning to explore blockchain. A few are conducting pilots, and others have moved even further and are working with supply chain partners to develop application. First, note that a blockchain is a distributed or decentralized ledger, which is a digital system for recording transactions among multiple parties in a verifiable, tamper-proof way. The ledger itself can be programmed to trigger transactions automatically. For cryptocurrency networks that are designed to replace fiat currencies, the main function of blockchain is to enable an unlimited number of anonymous parties to transact privately and securely with one another without a central intermediary. For supply chains, it is to allow a limited number of known parties to protect their business operations against malicious actors while supporting better performance. And successful blockchain applications for supply chains will require new permission blockchains, new standards for representing transactions on a block, and new rules to govern the system, which are all in various stages of being developed. Moving on to the advantages of blockchain. Led by companies such as Walmart and Procter & Gamble, considerable advancement in supply chain information sharing has taken place since the 1990s, thanks to the use of enterprise resource planning or ERP systems. However, the visibility remains a challenge in large supply chains involving complex transactions. To illustrate the limitations of the current world of financial ledger entries in ERP systems, along with the potential benefits of a world of blockchain, let me describe a hypothetical scenario, a simple transaction involving a retailer that sources a product from a supplier and a bank that provides the working capital the supplier needs to fill the order. The transaction involves information flows, inventory flows, and financial flows. Note that a given flow does not result in financial ledger entries at all 3 parties involved. In state-of-the-art ERP systems, manual audits and inspections cannot reliably connect the 3 flows, which makes it hard to eliminate execution errors, improve decision-making, and resolve supply chain conflicts. Execution errors such as mistakes in inventory data, missing shipments, duplicate payments are often impossible to detect in real time. Even when a problem is discovered after the fact, it is difficult and expensive to pinpoint its source or fix it by tracing the sequence of activities recorded in available ledger entries and documents, although ERP systems capture all types of flows. It can be tough to assess which journal entries, accounts receivable, payments, credit for returns, and so on correspond to which inventory transaction. And this is especially true for companies engaged in thousands of transactions each day across a large network of supply chain partners and products. Making matters worse, supply chain activities are often extremely complicated. And for example, orders, shipments, and payments may not sync up neatly because an order may be split into several shipments and corresponding invoices or multiple orders may be combined into a single shipment. One common approach to improving supply chain execution is to verify transactions through audits. Auditing is necessary for ensuring compliance with contracts, but it's of limited help in improving decision making to address operational deficiencies. Consider the problem a food company faces when its product reaches the end of their shelf life in a retail store. A study conducted recently was done with a major manufacturer of packaged foods, which found that an audit or an inspection of inventory in a store can reveal the number of expired items, but it won't explain causes. Those can include glitches in any part of the supply chain, such as inefficient inventory management upstream, suboptimal allocation of product to stores, weaker sporadic demand, and inadequate shelf rotation, or failure to put older products in front of newer ones. A record of all those activities can help reduce expirations. Another way to strengthen supply chain operations would be to mark inventory with either RFID tags or electronic product codes that adhere to GS1 standards or globally accepted rules for handling supply chain data, and then to integrate a company's ERP system with those of its supplier to construct a complete record of transactions. This would eliminate execution errors and improve traceability. However, the experiences of the companies show that integrating ERP systems is expensive and time consuming, and large organizations may have more than 100 legacy ERP systems, a result of organizational changes, mergers, and acquisitions over time. Those systems often do not easily communicate with one another and may even differ on how they define data fields. One large company, for example, had 17 ledgers and separate ERP systems associated with a single activity, trucking, and its suppliers and distributors have their own ledgers and ERP systems. When blockchain record keeping is used, assets such as units of inventory, orders, loans, and bills of lading are often unique identifiers which serve as digital tokens, similar to Bitcoin. Additionally, participants in the blockchain are given unique identifiers or digital signatures which they use to sign the blocks they add to the blockchain. Every step of transaction is then recorded on the blockchain as a transfer of the corresponding token from one participant to another. Consider how the transaction may look when represented on a shared blockchain. First, the retailer generates an order and sends it to the supplier. At this point, since no exchange of goods or services has taken place, there would be no interest in a financial ledger. However, with blockchain, the retailer records a digital token for the order. The supplier then logs in the order and confirms to the retailer that the order has been received. An action that again gets recorded on the blockchain but would not generate an entry in a financial ledger. Next, the supplier requests a working capital loan from the bank to finance the production of the goods. The bank verifies the order on the shared blockchain, approves the loan, and records the loan's digital token on the same blockchain, and so on. A blockchain is valuable partly because it comprises a chronological string of blocks integrating all three types of flows in the transaction and captures details that are not recorded in a financial ledger system. Moreover, each block is encrypted and distributed to all participants, who maintain their own copies of the blockchain. Thanks to these features, the blockchain provides a complete, trustworthy, and tamper-proof auditor of the three categories of activities in the supply chain. Blockchain thus greatly reduces, if not eliminates, the kind of execution, traceability, and coordination problems that have been discussed. Since participants have their own individual copy of the blockchain, each party can review the status of a transaction, identify errors, and hold counterparts responsible for their actions. And no participant can overwrite past data because doing so would entail having to rewrite all subsequent blocks on all shared copies of the blockchain. The bank in our example can also use the blockchain to improve supply chain financing. It makes better lending decisions because by viewing the blockchain, it can verify the transaction between the supplier and the retailer without having to conduct physical audits and financial reviews, which are tedious and error-prone processes. And including lending records in the blockchain along with data about invoicing, payments, and the physical movement of goods can make transactions more cost-effective, easier to audit, and less risky for all participants. And furthermore, many of these functions can be automated through smart contracts in which lines of computer code use data from the blockchain to verify when contractual obligations have been met and payments can be issued. And smart contracts can be programmed to assess the status of a transaction and automatically take actions such as releasing a payment, recording ledger entries, and flagging exceptions in need of manual intervention. It's important to note that a blockchain would not replace a broad range of transaction processing, accounting, and management control functions performed by ERP systems, such as invoicing, payment, and reporting. Indeed, the encrypted linked list or chain-like data structure of a blockchain is not suited for fast storage and retrieval or even efficient storage. Instead, the blockchain would interface with legacy systems across participating firms. Each firm would generate blocks of transaction from its internal ERP system and add them to the blockchain. This would make it easy to integrate various flows of transactions across firms. Now let's take a look at a few case studies. First one is Emerson, which is a multinational manufacturing and engineering company which has a complex supply chain. It involves thousands of components across many suppliers, customers, and location. The president has noted that such supply chains often have to contend with long, unpredictable lead times and lack of visibility. As a result, a small delay or disruption in any part of the supply chain can lead to excess inventory and stockouts in other parts. And he stated that blockchain can help overcome these challenges. Here's a simple illustration of the problem and how blockchain could address it. Consider product A, which uses components C1 and C2, and product B, which uses components C1 and C3. If the manufacturer of product B is held up because of a disruption in the production of component C3, the optimal move is to temporarily allocate inventory of C1 to product A until the disruption is resolved. However, if all products and components are manufactured by different companies with limited visibility into one another's inventory, what could easily happen is that excess inventory of C1 piles up at the company, making products B even if the maker of product A has a stockout of C1. One solution is for the companies in question to agree to centralize their data on production and inventory allocation decisions in a common repository. But imagine the level of integration that would entail. All involved companies would have to trust the other with their data and accept centralized decisions regardless of whether they're partners or competitors, which is not realistic. A more practical solution is for participating companies to share their inventory flows on a blockchain and allow each company to make its own decisions using common complete information. Companies would use a Kanban system to place orders with one another and manage production. Kanban cards would be assigned to the produced item, and the blockchain would record digital tokens representing the Kanban cards. This would enhance the visibility of inventory flows across companies and make lead times more practical. Emerson is not the only company that thinks blockchain could increase the efficiency and speed of its supply chain. So does Hayward, which is a multinational manufacturer of swimming pool equipment. Walmart is another example, which has been using blockchain with the trucking companies that transport its inventory. A shared blockchain makes it possible to synchronize logistics data, track shipments, and automate payments without requiring significant changes to the trucking firm's internal processes or information technology systems. Part of the appeal of using blockchain to enhance supply chain efficiency and speed is that these applications, much like those for improving traceability, require participating companies to share only limited data, in this case just inventory or shipment data. Moreover, these applications are useful even within large organizations with multiple ERP systems. Another example is improving financing, contracting, and international transactions. When inventory information and financial flows are shared among firms through a blockchain, significant gain in supply chain financing, contracting, and doing business internationally are possible. Consider the matter of financing. Banks that provide working capital and trade credit to firms face a well-known problem of information asymmetry regarding a borrower firm's business, the quality of its assets, and its liabilities. For example, a company might borrow money from several banks against the same asset, or request a loan for one purpose, then use it for another. Banks design their processes to control such risk, which increases transaction costs, slows down access to capital, and reduces the capital available to small firms. And such friction are detrimental not only to banks but also to firms that need cheap working capital. Another activity ripe for improvement is accounts payable management, an elaborate process that involves invoicing, reconciling invoices against purchase orders, keeping track of terms and payments, and conducting reviews and approvals at each step. Even though ERP systems have automated many of these steps, considerable manual intervention is still needed, and since neither of the transacting firms has complete information, conflicts often arise. A third area of opportunity is cross-border trade, which often involves manual processes, physical documents, many intermediaries, and multiple checks and verifications at port of entry and exit. Transactions are slow, costly, and plagued by low visibility into the status of shipments. The retailing and financial service companies we study are conducting pilot blockchain projects or developing platforms in all three areas. By connecting inventory, information, and financial flows and sharing them with all transacting parties, a blockchain enables companies to reconcile purchase orders, invoices, and payments much more easily and to track the progress of a transaction with counterparts. When the supplier receives an order, a bank with access to a blockchain can immediately provide the supplier with working capital. And when merchandise is delivered to the bank can promptly obtain payments. Since there is a readily available audit trail, reconciliations can be automated. Using smart applications that rely on the blockchain data, conflicts between the bank and the borrowing firm are eliminated. The companies mentioned here have found that using blockchain and supply chain management will require the creation of new rules because the needs of supply chain differ from those of cryptocurrency network in important ways. The blockchain protocol for the Bitcoin network is a marvelous system that simultaneously achieves several goals. It provides a remarkably secure, irrevocable record of financial transactions, minimizes the double spend problem, and provides proof of ownership of digital coin, and it does so without relying on a centralized authority and while allowing participants to remain anonymous and enter and exit the network freely. To achieve all of this, however, the Bitcoin network sacrifices speed, consumes a large amount of energy to mine Bitcoins, and has some vulnerability to hacking. Supply chains do not need to make the same trade-offs because they operate in a different way and have different characteristics. Supply chains require private blockchains among known parties, not open blockchains among anonymous users, so that members of a supply chain can ascertain the source and quality of their inventory. Each unit of it must be firmly copied with the identity of its particular owner at every step along the way.